6, and that's supposed to be multiplying by x times y. So you can get the formula here, x plus 4y, 2x plus 5y, 3x plus 6y. There you go, that's the formula for S. And all I gave you was how it works on E1 and how it works on E2. This is how I would do the calculation using the standard matrix idea. There's another way to do it, though. Yeah.
I thought things like E1 and E2 represented like 1, 0, 0, and 0, 1, 0, like that.
Yeah. So this is 1, 0, and this is 0, 1. So here's another way we could do the same example. Like if I want to calculate S of x comma y, and maybe this is even faster, right? Then this is equal to S of x times 1, 0 plus y times 0, 1. Do we agree? But if the linear transformation is homogeneous, I can pull x out, right? And I can pull y out, right? But I gave us, in the statement of the problem, that we know what S of 0, 1 is, and we know what S of 1, 0 is. Did I say 0? So that's x of what? 1, 2, 3. Y times what? 4, 5, 6. And of course, if you add those, same thing. So, I mean, which way do you want to think about it? With the idea of the standard matrix, or just with the idea of just straight using additivity and homogeneity? I mean, it's up to you. I would respect either solution here. Totally, both are totally legitimate. Hey, let's take a walk down memory lane and see what I did to the students in Math 221 last time I taught this course. I mean, the test I provided for them, not what I did to them. I don't do too. I'm nice. You took my mission. It's not that bad, is it? I mean, the quiz wasn't that bad. I heard it was just 10 points, but after we get past the idea it's just 10 points, it's mostly okay, right? No? If I doubled the value of the quiz, would you feel better about it? If I made that 10-point quiz 20 points? See, I see some people going, no, don't do that. You guys are funny. If I can find it. Test 1. All right. I would expect many of these questions are still reasonable. And let's see if we can understand the motivation for me asking these questions that I did. A 3 by 5. No. No good comes of this. I just did this in differential equations. Let's not do this. Because you make a certain mistake with a note card, it hurts me. But if you don't have the note card, I can be like, they forgot. And I feel better about it, right? If they have the note card and they still don't know how to do a major problem type that we spent a half hour on, I have no choice but to be mildly offended. I mean, I don't know. I'm not that offended. I try not to be. I want to be happy with you guys. I don't want to be angered by the test, you know? So I look for ways. You can have the note card if it makes you happy. I mean, does this make you happy to have a note card? I don't really care. What's that? What are you going to put? I know. What are you going to put on? That's my question, yeah. You can have a 3-inch by 5-inch card for the test. It's fine with me. I mean, I don't think it really changes anything in here. Honestly. Does it? Not really. I mean, you're welcome to have a 3-inch by 5-inch card in the test, sure. Go nuts. You could put like one matrix example on there. Maybe 2. 3 inches by 5 inches, not 3 foot by 5 foot. I know how you guys are. I did not say 3 by 5. I'm wise to these tricks.
Only 2-sided though?
Only two-sided, right? No writing on the middle, like in my Calc 3 a couple years ago.
Wait, what? How?
Yeah, he split it by the ply and wrote in the middle.
What? Whoa. Oh.
Yeah. It was, I don't remember how he did. Okay, well, I will go a couple minutes over, but I don't want to go too long over, so let's just get to it here. If possible, find values for A, B, C such that the solution set of this includes these points.
Are you waiting for something?
No, I'm just thinking about it. I don't know. That's a weird question.
It's worded pretty.
Yeah, it's worded unusually. But I guess what you would do is be what? You would just plug in these points, right?
Yeah.
And that would give you, for example, A plus B plus C equal to 0. B plus C equal, 2B plus 2C equal to 0. And 3C equal to 0. So it's 3 equations, 3 unknowns. Just,
Go ahead.
you have to think, right? Dangerous for me at this point in the day. Calculate the reduced row echelon form of this matrix. I often have very simple row reductions because I really hate grading row reductions. So, but yeah, it's true. Which is no guarantee. Like, I can try to make it a 4-step row reduction problem. That doesn't mean that you can't find a way to do it in 14 steps. Like, I know who you guys are, right? I mean, me in my current state of tiredness, I could find a way also,
Oh, one thing. You don't mind with us having 2 steps in one, right? If it's applicable?
Oh, yes, as long as you don't do 2 steps you can't do. Yeah.
Gotcha.
Like, you can't do,
Plus and then swap.
yeah. Here's the elementary matrix question. We have talked about those too, have we not? Oh, look, a symbolic problem. X plus 2y equal to A, 3x plus 7y equal to B for given constants. Write the system of equation, solve it either by multiplication by inverse or Cramer's rule. Well, this would be an eminently fair question given the mission problem I just gave you, right? Ooh, look at this. We haven't had any of these, but these are well within your grasp. Suppose you have 1 over x squared plus 2 over y squared equals to A, and minus 2 over x squared minus 4 over y squared equal to B. Look at that. See how I'd like to do this. See how I am? It's the same problem. Ah, wait. Oh, man. Ah, come on. Disappointing. I had such hope for this problem, just being the same one, but no. See, I had me going there for a second, but anyway, so something like this, you just make a substitution. See, this is linear in the variables 1 over x squared and 1 over y squared, right?
Would you make it like u equals 1 over s squared, v equals 1? Okay.
You can do the same things if you get like sums of sines, cosines, and like any favorite set of functions or whatever, as long as they appear linearly, you can make a substitution and solve it as a linear problem. No. Oh, look, A, B, calculate the product. Did you guys notice anything special? Anything special about B transpose B in that problem you had? It was what? What kind of matrix was it?
Is it
Any special pattern about this? It's a symmetric matrix is what I'm getting at. B transpose B will be symmetric.
What's the substitution on problem 5?
Oh, I have a solution. I'll post this and the solution for you guys. Assume A and B are invertible. Is this, if C is equal to this, is C invertible? How would you calculate this? You guys, this problem is harder for these folks because they don't have determinant. Well, did they? Oh, yeah, determinant. This is easy, right? A and B are invertible. The determinant of C is the determinant of A divided by the determinant of B. Determinant of A is non-zero. Determinant of B is non-zero. So the determinant of C is non-zero. So is C invertible? Yes. In fact, you could write down its inverse. Ooh, look at this. Ooh, this problem is a little bit sneaky. I give you A, I give you AB, calculate the determinant of B. Ooh, how are you going to do it? You don't have B. Oh no, no. Incorrect. That would hurt you. That would eat your time. Inverse is a weapon of last resort. That is a computationally intensive move. You got to think twice before you invert. If you calculate the determinant of AB, and you calculate the determinant of A, you know the determinant of AB is determinant A times determinant B.
Yeah.
So you have it. Oh, look at this. This is another way I prevent myself from doing row reduction, from grading row reductions. I do the row reduction for you. And then I ask you to interpret. So I can just grade the part you don't understand. I mean, the part you should understand. The part you will understand. You will understand. You can do it. What's that? I have a solution, I just don't have it open.
I just know if we've covered it yet.
Yeah, like day 2. Do you guys see test 1 solution sitting in here?
Sure,
Ooh. That wasn't it. I used to make crazy pictures with Dan on the computer. He liked to do it. That seems like cheating, but okay.
Performance just like when like what we've been doing with the regular solution set, right? Putting in terms of the
Yeah.
variables.
Yeah.
Yeah, so, okay.
I'm sorry, guys. Give me a second here. Do you guys see it yet? It all bleeds. My eyes are blurry this time of day.
let's just, you can find it at home and then upload it.
Found it.
Nice.
Just in time. So, there's the parametric form, right?
Oh,
Yeah.
so we have to put it like in a set notation.
This, oh, look at this. So this actually has a double meaning. See, because this, you can also read from this that the inverse of this matrix is that matrix, yeah? And so you can solve this problem using, see, because this is the super augmented matrix of the identity in that, right? So this is the inverse of that.
Okay. Nice.
And yes, so
Oh,
if you know that, you can solve by multiplication by inverse. Determinant problem, right-handed triple. Determinant gives you the volume, right? Remember that? I might ask a question about determinants being volume. And here's a traffic flow problem. Hooray. I don't see your test being that long because I'm tired of grading. So anyway, I will see you Tuesday. Hopefully we can still be friends after it.
So wait, when should we return this in then if we're not?
Tomorrow,
doing it today?
to turn in tomorrow in the math department. I have a mailbox it's the one with Cook, or in my office tomorrow if you find me. Yep. Either's good. Thanks, guys.